Hey yo, what's up? Again, this is the Daily Dean, and we are going to talk about astronauts, the International Space Station, and hydration. Just a couple things on my mind. So, first of all, I want you to imagine, this is actually based off a Vsauce video, kind of. This is where I learned it from. How far do you think the International Space Station, the ISS, floats away from the Earth? If we imagine we have oh, here we go. This is my charger for my watch. So if we imagine this is the Earth, okay, how far do you think the International Space Station floats away from it? Okay, do you think it floats, right here? Let me try and get a better look at that. Right here, way out here, when it orbits the Earth. In reality, in comparison to the Earth, it's barely touching it, right? Like in comparison, in relative size, right? So, with that in mind, it's kind of crazy to think the International Space Station ain't that far out. So, how does the International Space Station really orbit the Earth? Well, you have to imagine how gravity works in terms of like Newtonian physics, okay? When you see an apple fall, right, it goes straight to the ground, okay? When it goes straight to the ground, wind might push it, right? So, it might be falling, but then a force acts on it. I think that would be laterally, would be the word, and pushes it horizontally from your point of view. So, if wind is pushing against it, is there a point where the wind pushes so hard that the apple matches the curvature of the Earth, avoiding it entirely? Yes, that is the International Space Station. It's constantly falling to Earth as a result of gravity, and it results in this orbit, right, where it barely misses the orbit of Earth. Now, that means that gravity is still acting upon it, and people tend to think, oh, there's no gravity in space, but that's not true. Gravity is always everywhere, but it's just you're weightless in space, or you are experiencing very microgravity. Now, this was actually a fear NASA employees thought, right? They were like, what happens if we have like astronauts in space and they try eating and, they start choking, they start asphyxiating because the microgravity doesn't let them eat. Because they may have observed in birds use gravity to eat because they don't really chew their food, they just swallow it whole and let gravity do the rest of their work. But they wonder, like, hey, do humans also, like, what if we choke in, space? That does not happen. When you swallow your food, your muscles move it all the way down, so you do not choke, thankfully. But there was kind of a guess-a-roo, like, okay, are we gonna need to figure out some way to pump food into astronauts' mouths and stomachs and whatnot? Because if they can't swallow water, food, or drinks, how are you gonna get it down there? But no worries, they figured it out. Astronauts can eat in space, and it's because our muscles control our digestive tract. Now let's talk about the digestive tract. The digestive tract, is like related to hydration. That's actually what I wanted to talk about. Hydration is awesome. I love drinking water, and I can't emphasize that enough. If you follow my Instagram, you'll see that in my little bio is certified hydro homie. That's because water is frigging awesome. If you haven't drinking water today, I would highly recommend it. And lots of people think like, oh, what's a good amount of water to drink? Now, I tried researching this. I got a couple different answers, but the range is around 500 milliliters to 1200 milliliters. Okay, so basically, the sweet spot would be a water bottle, right? I don't actually have like let me try and give an example, like the Crystal Geyser, Kirkland water bottles that are like this big. That's 500 milliliters, about 16 fluid ounces, and that's a good amount of water to drink hourly. Okay, every hour you may want to be drinking, glug that, drink it up, and that's a good way to see, your hydration. But there's something also related to that. I hate the stigma around urine, because urine is an awesome way to see how hydrated you are. If your pee is like, very yellow, that's not great. But if it's like, onion yellow, if you have a picture of what an onion looks like, that kind of color, and your pee looks like that, that's freaking awesome. That's the great color of pee. Now, there's also this idea that clear pee is superior to yellow pee. That's, like, kind of understandable, right? Your pee is clear, therefore you're hydrated. But you don't want clear pee all the time. That means you're overworking your kidneys and they have to be flushing out all that water. So it's okay if you have clear pee like once a day or maybe twice a day, but if you keep having it, every single day, every single hour, that's not good. You don't want to be doing that to your kidneys. So, I would recommend trusting your urine. What color does it look like? Does it look like an onion yellow? Yellow onion, right? And if so, that's great. And if you need like a starting point, go around 500 milliliters and see how much water that, turns your pee into. And also, one other thing. People think that salt dehydrates you, but you can actually counteract that just by drinking water, right? It's surprising to think like, you can't counteract high cholesterol levels without like, a healthy diet or high sugar without exercise. But you can counteract high sodium levels just by drinking water. So if you eat a lot of salty food, like I don't actually know the amount, but if you feel like your mouth is really dry and you're gonna have some trouble, just drink water, and that's a great way to resolve that. So thank you for coming to my Daily Dean talk. This is going to be the first time I'm saying this, but, share the word of my stuff, because I'm glad to have you here. Thank you.